Hello again, everybody, and I want to just make another short video focusing on the relationships between classes. So I'll probably make a couple of these types of videos, but for this particular small short section, I want to focus on the concept of aggregations. So aggregations was asked a few times during classes this week, and inheritance was asked about. I'll do a separate video about that. But right now, I just want to focus on the relationships between classes whereby you would have what's called an aggregation, a composition. Okay, so in this video, the focus is going to be on the association between classes, aggregations, compositions, and the diamond notation that you use in the diagrams. You've got to make sure you get that correct, and the multiplicity in terms of 0 to many or 1 to many relationships. I'll talk about that in a minute. And then finally, how do you actually kind of represent that same aggregation in an entity relationship diagram? Okay, so here's the different types of relationships. I'm hoping to make a kind of a series of videos over the next day or so that you can just look back on before you submit your final assessment class diagram. Okay, so without further ado, let's just go back to our section here on Moodle, where you'll see assignment 3 has a whole range of videos after it explaining the assignment, but I'm adding these other sections here, and I'll cover the aggregations right now, the small section on database building, primary key, foreign key, which most of you have already done. Okay, so there's a little file here, glossary of terms. If we just open that file, here's pretty much all of the different representations of connecting classes in UML. So obviously you know a class diagram is represented as this kind of rectangular shape, but I think what I found in labs is the different associations, the different relationships between the classes. People seem to have a few little holes in their knowledge about that I want to clarify right now. So the first thing that I want to clarify is this multiplicity. You need to put the multiplicity in there, whether the number is known or not known. You might have a specific number. Generally speaking, most of the diagrams I've seen have a 1 to many or a 0 to many relationship. And it's important that you place that basically along the line of the kind of owner class. So the number of range just represents a specific interval, as it says here. Okay, so there was questions about the diamond and whether you need a partial kind of aggregation. It's a non-exclusive ownership. Like one class owns the other, and here's a full aggregation where it's exclusive ownership. Okay, and that's not the same as an association. Ownership and association are two different things. Okay, so let's just go and have a look at some sample classes before I sort of build one. Here's some basic aggregations. The white shaped diamond points towards the parent class. You can see here you've got an address book. Imagine a physical address book. You'd have a bunch of contacts in it. The contact is kind of owned by the parent class. You know, like it's important that you get this, because there's different types of relationships. This is a sort of a has relationship, whereas the inheritance, which we'll do in another video, is an is relationship. Okay, so let's just leave inheritance for now. We'll focus on associations. For example, a car has an engine, and a car has a wheel. A person has a leg. A book has a page. Okay, so you know there's a big difference between a full and a partial aggregation. Okay, so like a composition is where something is fully owned. It cannot exist independently. So if something cannot exist independently of the parent class, then you'd say it's owned by that class. Okay, so there's some examples here. So for example, a teacher-student relation is not really a composition. It's just an association. Like, I mean, the student is a 1 to many relationship between teacher and student. So, you know, in this situation here, like the student quite happily exists without the teacher, and the relationship, the multiplicity being placed beside the student, it basically says this student has a 1 to many relationship with the teacher, or the teacher has a 1 to many relationship with the student. So student and teacher can exist quite happily. Neither they're associated with each other. It's not an ownership relationship. It's just an association. Okay, so let's look at aggregation now. and aggregation is a little bit sort of a stronger relationship. So, for example, a car, has a wheel, and again, it's the parent class where the diamond is shaped. Okay, but like notice that this is just it's not a full aggregation. It's not like completely owned by it. The wheel can kind of exist independently of the car. Okay, it doesn't just cease to exist. Now you compare that to other things like that the only real reason it exists, like here, like person, leg, like a person. It's a bit of an extreme example, an anatomical example, but like the brain, heart, and legs generally can't exist independently of the person. It's just the sum of its parts, really. So that's why that is a strong aggregation, is what you'd call that. It's a strong composition, so it's fully owned. The parent class fully owns the instances of the composed class. Okay, so a little summary here you might see. So association is generally a relationship. Aggregation implies a sort of ownership relationship. So like you might have a generalized relationship here. So for example, teacher-student relationship is a good one. Aggregation can be a weak relationship where you'd have the partial diamond. Okay, so the sort of unfilled in diamond like that. And then you have the strong relationship, which is a full composition. Okay, so just the kind of terminology that would be used in this, most people just say compositions. Okay, so you talk about compositions when you look at a class diagram, especially those that you've seen in the notes. We see, and we've been kind of referring to these as compositions. Okay, whereas these payment, cash, credit is an inheritance, order and order detail is a composition. Okay, you'll notice too the order detail is a one-to-many relationship. You'll always have at least one order detail. But customer, you may not have a customer. A customer may not make orders, for example. So that's a zero to many. That's going to be kind of important when it gets to sale in your cases. Okay. So like you may not have a sale, you may not have any sales of your product. So just be sure to write that as a zero to many relationship. Okay, whereas this is a sort of order detail and item it's an association. Okay, so we'll worry about those as different terms later in a later video. I just want to kind of clear up that right now that how to draw this, and therefore we'll do some code and how to represent that in code also as I make further videos here. Okay, so composition, aggregation is what I want to focus on right now. Okay, so we'll just kind of look at some other examples here. Here's a nice little example. I think that should demonstrate it quite well, because you'll see all of these diamonds are not filled in because there's no real ownership here. I mean, it's a rental, and that's a great example, because a rental, you don't own the car. Okay, a rental object, a rental class, is like a parent class of a car, but the car exists to be for other reasons. Has other uses, and you can see that even right there. It's associated with the car company. It has a car company. The car company has a car, and a car company has a bunch of renters. It doesn't own those renters. The renter doesn't own the car. The rental doesn't own the renter. Just like the sort of teacher-student relationship. Okay. That's very different, for example, than situations where, let me just get another example here, like the car and the wheel. I mean, you can kind of just, I think that, it's arguable whether that's a composite relationship, but certainly the wheel and tire is definitely a composite relationship. Like a wheel of a car, like, the tire on its own just sort of ceases to be of any use without the wheel of the car. Okay, and that's very different, for example, than this little example that I have here, and this is also on Moodle. Like the seller, the salesperson, whatever you want to call that, makes a bunch of sales. The salesperson can do other jobs in the company. Maybe he's in charge of reviews or whatnot. That is a it's a partial composition, what we call an aggregation. It's not a full composition where you would fill in the diamond there. Okay, so this terminology, and I think as an introductory level, you might just kind of say compositions are everything, aggregations like all relationships that are kind of the same, but there's a subtle difference between them. And I think from what I can see, most people seem to be just having some kind of partial relationship or a full relationship. Okay. Now, I haven't included many in this because I don't want to overcomplicate it too much in explaining this. This diagram is on Moodle. You'll find it there if you just look at this particular slide here, sample basic classes aggregation, and there it is right there. Okay, but I want to just keep this open for a second because I'm gonna add a few more classes, and maybe as I'm adding it, you can be thinking yourself of what that type of relationship is. Is it a full aggregation, meaning the kind of colored in diamond, or is it a full aggregation, a composition, meaning the colored in diamond, or is it just a sort of partial composition and aggregation, meaning the the kind of whatever clear diamond. Okay, so I'm just going to go up and if you look at this, these all relate to the same thing. The entity relationship even is the same. Is kind of very similar. So there's an entity relationship diagram on that same page on Moodle. I'll just open that. So there's a basic EORD for the exact same relationship. So here's the EORD for the same thing. So you've got car, sale, seller. Once again, the parent table in this case is where you draw the crow's feet. And again, you've got multiplicity. It's one to many. A subtle difference, but the main thing to remember for the tables is that the foreign keys all go in the parent class. Now I say parent here not in terms of generalization or inheritance. I mean the owner. Let's call it the owner class, okay? Because when I think people hear parent class, they're thinking about inheritance. So I'm going to use the term owner class or associated owner in this situation. Okay, so like a sale kind of partially owns. It's not a full composition. The sale doesn't own the seller does other jobs, and likewise, many cars are sold elsewhere. So that relationship is an aggregation, and the foreign keys are drawn in the sale class when this is the EORD you're doing, and when you are drawing the class diagram, it looks very similar, but the diamonds are drawn again on the sort of the owner class for just to use that term. Okay, so let's look at some other examples just that you might find your own project in them in some capacity. So here's like continent has countries. Okay, there's several countries, so it's a one to many relationship. The continent is kind of the container class. Think of it as a container or owner. Okay. So a continent contains several countries. A country contains several capital towns, frontier borders, roads. Okay, and again, these are all kind of partial aggregation. The road exists. Maybe it flows into another country, for example. So the main thing to understand here is that this is not an inheritance. Okay, inheritance is entirely different. I'll do another video about that. I just thought people were getting a little confused in labs between drawing an inheritance, which is this notation with the arrow, and this kind of aggregation composition, which is this notation with the diamonds. All right. So I've asked you in the actual brief anyway, specifically to produce two aggregations. Okay, so if we look at the brief there, we'll see, it's very clear you need a kind of partial composition and aggregation and a full composition. Okay, and if you feel free to add more, I'll choose the best ones for grading. But I think to kind of call yourself any kind of a software engineer, you'd want to have done a good range of these relationships. So at least the two types of aggregation composition, an aggregate partial ownership, an aggregation, a full ownership composition, and a generalization or an inheritance. Now there are different types of inheritance. That's why people often have gotten confused. We'll talk about that in the next video. You have multiple inheritance. You get triple generations and things like that. We'll deal with that in another video. This video is about associations, meaning the aggregations and the compositions. Okay, so just a couple of final words then before I wrap it up. The video is getting quite long there. Is the, if to add more classes, okay, if you want to add more classes, I mean, I've asked people to do fairly large sets of a class diagram structure, in particular if they're a group of 4, and there are several groups of 4 now. And quite frankly, even if you're a group of 2, you still should be thinking about doing everything that the brief requires: 2 types of compositions and at least 1 inheritance. And you can see in this one, for example, it's got 1 inheritance system, payment, cash, wire transfer, etc. They're all different types of payment. So you say the terminology for this would be a cash payment is a cash class is a type of payment. A check is a type of payment. Whereas in this situation, you're talking an order detail. You're saying an order detail is contained in an order. So an order contains order details. So you've got this order contains one to many order details. Okay? Order details order detail is associated with 0 to many items. Okay? So you can easily scale this up. That's the whole point of what we were really getting at with all this. The whole concept of object-oriented programming is for scalability, maintainability, reusability, among other things. And that's quite impossible to do if you just sort of draw your user interface, don't give any thought to the data structures that you're planning to use for even objects, or just to save data in memory. And this is the reason that in general you would do your class diagram first. It's not a really common practice to jump straight into the interface. That's pretty bad practice, I would say, to jump straight into the user interface without at least addressing the database, which is what you've done. But it would be preferable if you actually address the class diagram first. Now, I know I talked about that in lectures, that you can't really do that because you weren't prepared enough for the, you're at the student level. Students tended to go for the ERD first, okay, and design their ERD completely before moving ahead in the class diagram. Now, when it comes to assignment 4, the debugging section, we can readdress all of that, okay. We can come into assignment 4 and we can sort of find problems that might have been entered into our class diagrams through unit testing and fix them, okay. So let's just take a look at this anyway. A class diagram, this is generally RAM. This is, memory, random access memory. It's not something that it's volatile storage. RAM is volatile storage. It's not permanent storage. And you're really dealing with sort of a system of memory management when working with a class diagram. So before anything gets saved to the database, this is how it should be considered. And that's what software engineering is. It's the whole concept of memory management, management of volatile storage, and management of permanent storage. But anyway, let's get just kind of back to one more association. And I want to really make sure that everyone's clear on that. So I hope this video is helpful. And I'm going to do two final ones. And as I'm doing them, you might think about it. I'll just pause for a second, and you can think about the type of relationships. So I'm going to make here a payment, and I'll make here one that a lot of people seem to be doing, which is a review. Okay. So again, this is all about scalability. These are the extra little things that you may not have actually managed to do for your requirements implementation this time around, but you might do it for the assignment 4 when you address your testing. You test it and realize that the review section wasn't done, so you have to do it for the final assignment and upload. Okay, so I'm just adding these there and thinking about, well, where would they go? All right, so what would they be? First of all, where would they be connected to? Okay, so you can see clearly that there has to be some connection somewhere. They don't just exist there on their own in some kind of a void. So, what do we connect this to? Do we connect payment to seller? Well, I would not say so. I would say we need to connect payment to sale. Okay, and that's basically going to be a kind of aggregate. It's a relationship. It's a composition. It's a composition. Okay, but is it the weak composition or is it the strong composition? Okay, in terms of seller, like the seller goes off and probably does other things within this system. Maybe the seller, the sales team update cars, the sales team do brochures and reviews and everything else. So that's kind of like, you know, the teacher student relationship. Really, it's not quite just association. The sale is composed of a seller. A sale is composed of a seller, but the seller does other things, and we could make a lot of other classes to connect to seller. Payment, on the other hand, is not. Payment has one function. The only reason that payment exists is to sort out a sale. Okay? And that payment relationship is therefore marked here in black. It's fully owned by the sale. The sale does not own the seller. Yes, the sale contains the seller, but it doesn't own the seller. The sellers quite happily can exist doing other jobs and marketing or whatever they do in that company. But this payment class does not exist for any other reason. Okay, so that's why we write that in as the kind of filled in diamond there. So now we want to concentrate on multiplicity, and you always write the multiplicity beside the class you refer to. So I'm just going to write this beside, you know, the payment class. So it's a one-to-one relationship. So you'll say one sale, one payment. Okay, we're not doing, you know, this is not Little House on the Prairie where you can go down to the little store and give them $1 a week or something, you know. This is just a one sale, one payment. Okay, one-to-one relationship. And review will be quite similar. So let's take a look at review. So you want to review a car? Well, this is an interesting one because, okay, so where's the relationship here? Okay, so you talk about a car and a review. Well, this is more of a, you know, this is an ownership really, because you're going to see a product. If you look on Amazon.com, you've got a product, and that product will be associated with a whole range of reviews. Okay, and essentially it owns those reviews. Those reviews have no business being on Amazon's website if that product ceased to exist. So if the car, being like the product, just was no longer, you know, there, like the make and the model, let's, I don't know, whatever your favorite car is. If you're selling car, make, Ford, model, number, whatever, and that car ceased to be on your sales list, well, all the reviews are disappear with it, don't they? So, like, you're selling your Nissan Leaf, a nice electric car or whatever it is. If the Nissan Leaf ceases to be used, all the Nissan Leaf reviews just disappear with it. Okay, so that's a full aggregation. Now, I've got that wrong. Okay, I'm glad I got that wrong because I can correct it right here in front of you. Okay, it's actually owned by the car. Okay, so that's very good. So if you stopped watching the video, you don't see me correct that. Okay, so this is the whole point of kind of software engineering systems analysis. You do have to sort of, you know, like review things and draft things multiple times. Okay, so I'm going to write the multiplicity to the class here, so it's nearest. So that's a 1 to many. Okay, it's actually 0 to many because there may not be any reviews. Okay, 0 to many. Okay, so for example, a seller and a sale is definitely a 1 to many. You just can't have a sale with a seller. You know, you're going to have cars, 1 to many sales. It may have, you have several sales. You may not have a single review though. Okay, but you will have a car sitting in your showroom, waiting to be sold. So you're definitely going to have at least one car there. But there may not be any reviews. It happens all the time. Okay, so that's pretty much where I'd like to end things there. So here is a class diagram containing 5 classes. All of them are a combination of relationships which are aggregations. They're a combination of relationships which are aggregations and compositions. Okay, that's basically the ownership or composed of class, or contains relationships. Um, Full containment, partial containment, aggregation. Okay, so these terms are going to be used kind of quite fluently over the next week or two, and you need to get them right. Okay, you can't just be saying that everything is a full composition. Not everything is a full composition. There's aggregations. It's kind of this partial composition, and it's the same with the generalizations, which we'll get to in the next video.